All right, so in this video, we're going to talk about the periodic table. All right, and we're going to talk about structure, how it's categorized, and what information we could figure out. Okay, so the periodic table is actually broken up into three main groups. All right, so the three main groups are we have here, which are these are your metals. Okay. Then we have this group over here. All right. This group here is your metalloids. All right. And then last, there's a group over here at the very edge at the end. And this group is your nonmetals. Okay. And so let's kind of talk about each of these, some of the characteristics of each of these groups. So now when it comes to the metals, all right, the first group that I talked about, some of the physical characteristic of metals is that metals, oftentimes they're shiny, okay? They're also usually solid at room temperature, okay? There's one big exception to this, and that's mercury. All right, mercury is the only one that's liquid at room temperature. All right. They're good conductors of electricity, of heat. Okay. They usually cannot be broken, but they're usually malleable, so that means they could be bent. They're ductile. All right, and so that's a really neat feature about metals. All right, they could be pounded into different shapes rather than being shattered. Okay, and then we just notice it's mostly on that left side of the periodic table where we have our metals. Now, most of the elements of the periodic table are metals. About 80% of all the elements that we know of are all metals. Okay. Now we have this middle section here that I kind of talked about earlier. Your metalloids. All right, so it's kind of like this section here. We have our metalloids. And they're kind of located around this zigzag area between your metals and your non-metals. Now, there's debate about what elements is considered to be a metalloid. So different periodic tables will list different elements within this general area here as what is a if it's considered to be a metalloid or not. It's kind of up to debate, but anyways, there is kind of some general rules with metalloids anyways, and as for its properties. And the reason why it's called metalloids is because it's somewhat of an intermediate between metals and non-metals. Okay, so metalloids, particularly, they may not be as good as a conductor as metals, but they're not as poor as your non-metals. Okay, sometimes they may appear to be lustrous or shiny like your metals, and then they are brittle just like your non-metals. Okay. And so it has some really interesting chemical behaviors, as they may not conduct electricity as well, as I said, but that could be really, really important in some applications. Okay, like for example, semiconductors. Semiconductors are made up of metalloids, and why do we use metalloids? Because they don't conduct electricity as well, and that's pretty good for like circuitries and stuff like that. What powers your cell phone, your laptops, and most electronic devices that we use nowadays. Versus you wouldn't want to use copper because copper, much like your all your other metals, conduct electricity, too well in this case, in this application. But then if you're talking about lighting your house, you want something that conducts electricity really, really well. Okay, and then your last column here, your non-metals. Okay, all your non-metals are all poor conductors of electricity and heat. They are brittle. Okay, they typically are dull in color if you find them in its solid state. So, like for example, sulfur, phosphorus, Selenium. I mean, they're not necessarily very shiny elements. I mean, they're very dull. They look like rocks, if anything else, or colored rocks. It kind of depends on which ones we're talking about. Sulfur typically is it's a yellow base color, and then phosphorus, it just depends on which isotope we're talking about. Um, but most of it, oh, not most of it, but a good number of our nonmetals at room temperature are in a gaseous state. All right. And so you have like nitrogen, oxygen, fluorine, chlorine, all your noble gases, really. Well, except for this bottom one here. Nobody really knows how that looks like. But all these guys are gas at room temperature. So and so that's what's kind of a big thing about these non-metals. Now in the center here, okay, we have what we call, it's kind of like a subgroup per se. We have our transition metals. Now, transition metals are the metals that we typically know as metals, right? So, for example, we have iron here, nickel, copper, zinc, chromium, silver, gold, mercury. So these are the ones that we're typically we know something or much about. Platinum. So these are the metals that we typically know. Titanium. All right. As I said, I mean, good conductors of electricity, strong, firm, lush, shiny appearance, and so on and so forth. So here we got our transitions. And then we also have a very interesting category down here. All right. Of these two rows of 14, these are your, what we call the inner transition metals. Okay. They're a little bit more rare to find, and sometimes almost impossible to tell one from the other. And these elements are one of the last group of elements that were discovered after the 1860s, when there was a huge push on figuring out how many elements really exist, right? And so these are one of the last group of elements that been found. So here we got what we call the inner transition metals. Okay. Or other words, you have the lanthanide series, which is at the top row, and then you have the actinide series, which is the bottom row. But they act like all the other metals that we've discussed earlier. So another way that we could classify elements on the periodic table is kind of based off its chemical behavior. And there's really interesting ways that the periodic table actually shows us, okay? The first way I want to show you guys is a way that we classify elements is through what we call periods. Now, periods is basically elements that are in the same row. All right, so here this is period number 2 because it's the second row. All right, and so, and we'll talk about this in more detail in a later unit, but elements within the same row have the same number of energy levels. If I want to say, like, energy levels is where electrons reside around the nucleus. Okay, and so, like this one here, the second one I illustrated first, all right, as I said, is in the second period. And so they all have 2 energy levels. Those in the first period, all right, all have 1 energy level. Those in the third period all have 3 energy levels, and then so on and so forth. And it follows that particular order, okay? Now, another way that we tend to classify elements on the periodic table, other than using periods, is what we call groups. Now, groups are elements that reside in the same column. So, like, this first column here, and then we have the second column here, and then we got this third column here. All right, and so these are what we call groups. Now, interestingly enough, these groups oftentimes, and some certain groups more profound than others, have very, very similar characteristics. Okay, And so to the point that we will actually give that group a particular name because these elements, they act alike. All right. Sometimes we call groups families. All right. So because, as I said, these elements within the same column tend to act alike or very similar to one another. And so let's kind of talk about some of these groups. All right. And so like the first one I want to illustrate or I want to talk about, not illustrate, but someone to talk about is this first group here. And this group we usually call the alkali metals. All right. So why do we call the alkali metals? As I said, it's because they act alike. Okay. So like, for example, you cannot find these elements in its pure form in nature. All right. You will find them within the compounds. Why is that the case? These metals are highly reactive. All right. They're also very soft metals. I had the chance to work with lithium, sodium, potassium before, and you could really just take a butter knife and cut right through it. And so they're relatively soft metals. They also have, for a metal, they have typically a low melting point. All right. And one of the big things about them, they react rapidly, in some cases violently with water. I mean, you put potassium into water and you get fireworks, purple fireworks, but you get some fireworks, and that's just potassium reacting with water to make a alkaline compound. Okay, and that's why it's called the alkali metals, because when it reacts with water, it makes a basic or alkaline solution. Okay, so this first column here, we have the alkali metals. All right, this next column here, we have what's called the alkaline earth metals. Okay, so beryllium, magnesium, calcium, strontium, barium, radium. All right, we have the alkaline earth metals. Now, the alkaline earth metals, they have similar properties as the column before, the alkali metals, but they don't react as violently as the alkali metals. All right. They are typically lustrous, silvery metals. They're not as soft as the alkali metals. But as I said, they do react with water, but just not as violent. Okay. And if we go to the other side of the group, and we're going to talk about another major group here, we have this group. All right. And this group we call the halogens. All right. So it consists of fluorine, chlorine, bromine, iodine, astatine, tennessine, which astatine and tennessium, there's not really much application for those two elements. But if anything else, they're very corrosive nonmetals. All are found in nature, typically combined with other elements, much like the alkaline earth metals that we talked about earlier. So here with the halogens, we have to basically go through experimentation in order to purify these elements out of the compounds. But when they're combined with other metals, they create what we call salts. All right. So like, for example, we have this chlorine here, right? What other metal do we know that chlorine typically likes to bond to? Well, that's sodium, right? Sodium chloride, that's what we call table salt. But it's not the only salt. Any ionic compound, and we're going to talk more about this in a later unit, but any compound that's bonded to these halogens, we typically call them a salt. All right. But as the pure form, they can be kind of toxic. Chlorine, fluorine gases is not something that you definitely want to breathe in. Bromine, iodine as well. These are not substances that you really want to get into contact with directly. They tend to be toxic to us. But they're really, really interesting chemical properties. All right. And then last but not least, and I say some of the most interesting ones, is the very last group here, in which we call the noble gases. All right. And so here, this group here, the noble gases, which includes helium, neon, argon, krypton, xenon or xenon, and radon. Okay. Now, the noble gases, one of the interesting ideas of noble gases is that all of them are typically they're colorless gases. All right, they are inert. All right, and what it means by inert, they do not readily react with anything. Okay, I mean more specifically, your first three like helium, neon, argon. I mean, it's almost impossible to get these three elements to react with any other element or any other type of atom. I mean, you can, but it takes tons and tons of energy. While krypton, xenon, and radon, they can react with other elements, but there's just not many that they will react to readily. Okay, so they're inert. One of the reasons why they call a noble gas because of its inertness, right? If that's a word. But its inability, or not inability, but it's because the atoms in itself and how stable they are. There is no need for a chemical reaction to reach stability because it, in its natural, pure elemental state, it is stable. All right, and then we'll talk more about what does it mean and how does it look like. How does an atom look like when it is stable? And if an atom is not stable, what would they do? All right, but we'll talk about that a little bit later. But most importantly, we just got to know that noble gases, the atoms are stable, so they pretty much in many ways refuse. In simple terms, to react with any other atoms. All right, and so this is kind of just a little summary of the breakdown of the periodic table.